So yesterday we talked about the trig functions, sine, cosine, and tangent. Today we're going to talk about their inverses. When I talk about inverse functions, I'm talking about like mathematical opposites. So if we think about like addition, its inverse is subtraction. If you think about multiplication, its inverse is division. So we're undoing things, right? The opposite of something. So I just want to give us a little example here. If I wrote the equation, the square root of x equals 5, and I was trying to solve for that x, I would have to do the inverse function. What would be the inverse function in this example here? How would I undo that? What's the opposite of a square root, Dahlia? Yeah, we would square both sides. So that is the inverse function here, or inverse operation. Now it would be silly, and I'm going to write this off here as an example so you can see how silly it is, if I took that and instead of doing the inverse operation, wouldn't it be silly if I divided by a radical x instead? That doesn't make any sense. We can't just pick any operation to be the inverse of a specific operation like a square root. A square root has a specific inverse operation. It's squaring it. So that's the same logic that we're going to apply here when we talk about inverse operations for trig functions. We're not doing division. We're not doing subtraction. Each operation has its own inverse. So let's take a look at this triangle. In today's lesson, we are finding missing angles. Yesterday, we were focused on finding missing sides. Today, it's all about angles. So the angle that I'm looking for is an A. We usually use capital letters to indicate angles. So if you see a capital letter, that's usually the angle. In relation to A, 3 is the opposite, 5 is the hypotenuse, and 4 is the adjacent. So when I start this problem and I'm trying to find A, let's find sine A. Sine we know is opposite over hypotenuse. It's that so part. So I'm going to write opposite, 3, over hypotenuse, 5. That's like my pretty standard trig setup here. Sine of A, where A is the angle, equals 3 over 5. But we're trying to find A. So A currently is trapped next to this side. This is not multiplication here. So I do not want to see anybody saying divide by sine on both sides. That is not the inverse of sine. The inverse of sine is its own special function where we take sine, I'm going to change color. Sine inverse, which is where I write sine with a -1 up there. So sine inverse of the left side, which is sine A. And what I do to one side, I have to do to the other. So sine inverse of the right side, 3/5. A sine inverse cancels out a regular sine. So all I'm left with on the left side should be that angle A. And what I have on the right side is sine inverse of 3/5. And that is what I'm about to put into my calculator. So let's go to my calculator. I'll show you where the buttons are. Again, make sure your calculator is in degrees, not radians. To get the inverse button, I hit second. So yours should probably be a blue button that says second. And then you go to the sine button and it says sine -1 there. That's our sine inverse button. And then I already forgot what my numbers were. 3 over 5. So then I do 3 divided by 5. I close my parentheses and I hit enter. The answer that we're getting out anytime we do an inverse is an angle measure. So the angle measure for angle A is 36.9 degrees. Did anybody not get that? Okay. I'm going to show you the setups for the other two as well. Keep in mind, I'm still looking for angle A in this same triangle. So I should be getting the same answers because I just found what angle A is. I'm just going to set it up in 2 different ways. So for cosine, that would look like 4 over 5, adjacent over hypotenuse. Guess what? The opposite, the inverse of cosine, is called inverse cosine. So I'm doing inverse cosine of both sides here. Inverse cosine cancels out cosine. And I'm left with A equals cosine inverse of 4/5. And that's what I'm plugging into my calculator, cosine inverse of 4/5. And just to prove that it does get me the same answer, I hit second cosine, 4 divided by 5, close parentheses, 36.9. If you don't believe me, we're going to do it one more time with tangent. Again, same deal. I'm going to do opposite over adjacent. The inverse of tangent is tangent inverse. I'm going to run out of room over here. So tangent inverse of both sides. So tangent inverse of tangent A, tangent inverse of 3/4. Tangent inverse cancels out regular tangent. I'm left with A equals tangent inverse of 3/4. And just to prove that it gets us the same answer, tangent inverse of 3 divided by 4, 36.9. Any questions on this? I won't make us do every single one of these examples, but let's hit a couple of them. So let's take a look at number 1. The first thing I'm going to do is look at where is my angle that I'm looking for, and what sides do I have in relation to that angle. It is quite possible that you will have all 3 sides in a triangle like this. Sometimes you might only have 2. If you have 3, that's great. You have multiple options to set up. Here, it makes it very clear that we only have the hypotenuse and the opposite. So I only have the option to use sine. When I set this up, like I told you yesterday, we're going to write the trig function name, then the name of the angle. This time we don't have that name of the angle or the angle measure, so we're going to put the x right next to the sine. And on the other side of the equal sign, that is where my ratio goes, 6.5 over 10. Now that x is trapped in there, I do not want to see anybody trying to divide by sine anything. To get rid of that sign, we are doing inverse sine of both sides. Inverse sine cancels out regular sine. I'm left with x equals sine inverse of 6.5 over 10. Now that step in purple is kind of just like a step to get us used to doing sine inverse of both sides. If you do not show that in your work, that is okay. But the other 2 steps I've done so far, I definitely need to see in your work, or you will only earn partial credit for that problem. So I need to see the initial setup, and then I need to see the final step where you solved for x. Then you can just plug it in your calculator, sine inverse of 6.5 over 10. Sine inverse, 6.5 divided by 10, 40.5. And our answer should always be in degrees because we are always looking for an angle measure. Any questions on that? Let's do 3. I'll skip 2. What do we think for number 3? Which trig function are we going to use here in number 3? Here's my angle. Dahlia? Tangent, I have opposite and adjacent. So tangent, I'm going to start with tan. Then that's when I write my angle measure. Do I have an angle measure? No. So that's where the x goes. Oh, that's not what I meant to do. That's where the x goes. Equals opposite over adjacent, 4 over 5. If you want to skip the next step where you do the tangent inverse of both sides, that's fine by me. I'm going to write it like this. Tan inverse, tan inverse. So I'm left with, tan inverse cancels out tan. X equals, tangent inverse of 4/5. And then that's when I plug it into my calculator. Tangent inverse, 4 divided by 5. 38.7 degrees. Everybody good with that? Okay, flip it over. We'll just keep going with these ones. Let's do number 6, and then I'll do the last problem and we'll be done. Which trig function do we want to use for number 6? Casper? Cosine. I have the adjacent side here, and I have the hypotenuse side over here. So that's going to be cosine. Cosine of my angle x equals adjacent 10 over hypotenuse 27. To get rid of cosine, I need to do cosine inverse of both sides, which leaves me with x equals cosine inverse 10 over 27. Plug it into my calculator. 68.3 degrees is what I got. Any questions on that? Okay, I'm going to do the last one because it's a little bit of a weird word problem here. Number 8 says, without using a calculator, find the angle whose tangent equals 1 and explain. So I have a couple questions about this, actually. How do we do these without a calculator? Here's one of the methods. So let's think about a triangle. I know in this triangle, nondescript triangle here, right triangle, that I'm looking for an angle called x. So I'm going to highlight that as x. I want the tangent of that angle x to equal 1. What's another way that we can write 1 as a ratio? Dahlia. And tangent represents the ratio of which two sides? Opposite and adjacent. So if I look at that angle x in this nondescript triangle that I wrote, and I put the opposite as 1 and the adjacent is 1, 1 and 1, what kind of triangle do I now have? Dahlia. How do you know it's 45, 45, 90? The hypotenuse would be square root of 2. The legs are congruent, which means these base angles are congruent, which means they each have to be 45 degrees. So without using a calculator, with just using my special right triangles, I just discovered that x has to be 45 degrees. Any questions on that? Kind of a weird one. All right, your homework is in Math Lab. Go ahead and get to it.